today's class: database design, data structure, and algorithm. Okay, I believe everybody can see my screen, or I'm sharing my screen already. So last week we started with what is database and what is database management. So we are going to do a brief recap of where we stopped from last week. So the first thing which we established last week was what is a database. And from there we talked about characteristics of database and database management. So database is a collection of related data, and data is a collection of facts and figures that can be processed to produce information. The simplest explanation of this thing is, this definition is, take for instance, this is 300 level computer science department. Now you are offering perhaps, let's say, 5 or 6 courses. At the end of the day, each of these courses which you are doing, you will do assignments, you will do tests, your attendance is also there. So at the end of the day, all these things which are gathered are called data. They are called data. By the end of the day, after your exams, everything will be merged together. From there, the lecturers will be able to determine who have A, who have B, and who have C. So at the end before that, each of these marks which you are getting are being called data. Most of the times, when an individual, a different entity, sees it, it might not really make sense to him or her. But at the end of the day, when this data is being processed, it becomes an information, making it easy for anybody that picks it up to understand what is being written. So that is the most simplest definition of what this place is saying. So your database is a collection of different data, collection of different facts. At the end of the day, when it is being processed, looking at it, okay, you could actually correlate each of the information which is there, because you understand that your database is in rows and columns. Okay, we talked about that. We talked about database management. A database management system stores information in such a way that it becomes easier to retrieve, manipulate, and produce information. This is the okay, now what is the characteristics of database? One of the characteristics of database is the real-world entity. First is the real-world entity. The second one is the related base table. Third one is the isolation and data. So isolation of data and application. Isolation of data and application, less redundancy, consistency. These are all the things which we did last week. Okay. We should also understand that the essence of this modern day database is that it adds security, which is very, very paramount. It adds security in a situation whereby your facts, your data are not protected. In a situation whereby natural disaster, the occurrence of natural disaster or artificial disaster, your normal data, take for instance where you keep your files, you keep your information, if you don't have a digital format of it, you understand that it is at risk, and anything can happen to it at any time. Okay. From there we'll be going to something that is called users in database. Users. There are 3 users of a database. There are 3 users of a database. Okay, a typical database has users with different rights and permission. They have different rights and permission who use it for different purposes. Some users retrieve data and back it up. The users of a database can broadly be categorized as the following. The administrators. The administrators can manipulate the database. The administrators are the ones that are in charge of imputing data. They are in charge of either deleting, manipulating, or inserting data. They are the administrators. They are called the front end. They are called the front end users. They are called the front end users because they are the one that is in charge of imputing this data. They are the one in charge of taking records of this data. So these are the first users of a database, the administrators. Then the second user of a database is the designers. The designers are actually the group of people that design the part of database. They keep a close watch on what data should be kept and in what format. They keep record of what they keep watch of what data should be kept and in what format. For instance, your characters are stored in the format of text. They are stored in the format of text. Take note of that. Then your videos or your pictures are stored in the format of JPEG. They are stored in the format. These are the things which we have to take note of. These are the things which we have to take note of. Then another user of a database is the end users. They are the end users. End users are those who actually reap the benefit of having a DBMS, that is the database management system. End users can range from simply viewers who pay attention to the logs or market rates to sophisticated users such as business analysts. So most of the times, you and I can be regarded as the end users because what end users do, what we actually do is we don't have a direct interaction with the database. It is what is displayed what is displayed that we see. We don't have the access to manipulate them. We don't have access to manipulate the data. We only view them. We can only view them and take analysis and take deduction from them. DBMS architecture. DBMS architecture. By now, you should understand the meaning of DBMS. When I say DBMS, means database management system. So we are talking about the architecture of database management system. What is a database management system, first of all? You should understand that database is categorized into 3. Your database is categorized into 3. The first one is we have your centralized kind of database. We have decentralized kind of database, and we have hierarchical database. What are these kind of database? Firstly, your centralized kind of centralized database is a database which have all the whole pools of information. The pool of information is located in one resource. The pool of information is accessed from one single resource. Everything you need is in that single pool. That is what is called a centralized kind of database. Then a decentralized kind of database is a database in which information needed per time are spread across different databases, decentralized pools of information. Sometimes you have, in situation like this, you have it is being implemented with hyperlinks. You discover that for you to get an information, you have to leave the present data, the present database which you are in, to another one. And how you do that is most of the time is by hyperlinks. So hyperlinks is actually it is an indicator to where an information lies. So from that place, you can go migrate to a different database entirely. Then hierarchical kind of database is a database in which users are given permission for information. Users, depending on your access, the access granted unto you, depending on the access granted unto you, that the access determines the kind of information which you can have access to. You take, for instance, in an organization, you have the managing director, you have the marketing department, you have the accounting department. All these entities here, they have access to different levels of information. So the marketing department could only access information that can enable them to carry out what they are doing in the marketing aspect. So for your accounting department have information which will enable them to carry out whatever transaction or to carry out their job description. The managing director or the CEO should have the ultimate access. He or she should have access to all the information that concerns that organization. So for the accounting department, they have nothing to do with the information that the marketing department have. There will be no need for that. The vice versa. So that is what hierarchical database is all about. Okay. Understand that these three things, there are examples of this kind of database. Perhaps I believe that is going to be our assignment for today. We're going to be writing based on these three kind of database. You should be able to give examples of each one of them. Okay. Okay, talking about your database architecture. Your database architecture is in 3 tiers. We have tier 1, tier 2, and tier 3. Your database architecture is in 3 tiers. Database architecture focus on the design, development, implementation, and maintenance of computer programs that store and organize information. That is what database architecture is. It focuses, number 1, on the design, second, the development, thirdly, implementation, fourth, maintenance of computer programs that store and organize information. The first architecture of a database is tier 1 architecture. Tier 1 architecture. In a tier 1 architecture, the database management is only the entity whereby users directly sits on the database. Okay. This is what this place is. Tier 1 architecture is telling you this, that database design and programs normally prefer to use single tier architecture, which is a 1-tier architecture involving putting all the required components. All the required components now, which I'm talking about, is number 1, the information, the database itself, and the interface which you use to access this database. All of them are sitting down on one component. So tier 1 architecture involves putting all the components, the required components, which I just mentioned, for software application or technology on a single server or platform. So all the whole information, all the whole components which are needed reside on the server. The number one, the interface is there. Then the software which you use to manipulate the database is also sitting on the server. That is basically what tier 1 architecture is telling you. Basically, a tier 1 architecture keeps all the elements of an application, including the interface, middleware, and back-end data in one place. That is the summary of tier 1 architecture. Then in tier 2 architecture, it must have an application through which the database management can be accessed. There is an application through which the database can be accessed. So in your tier 2 architecture, software architecture in which represents a layer or interface run on the client, and a data layer or a data structure gets stored information which is residing on the server. So for instance, what this place is telling you for your tier 2 architecture, your database is residing on a different server entirely, and the application which you use which fetches this information resides on a different server entirely. The application you use a different application entirely, residing on a different server to manipulate information. This is what tier 2 architecture is telling you. Then for your tier 3 architecture, separates its tiers from each other based on the complexity of the users and how they use the data present in the database. A tier 2 architecture is a client-server architecture in which the functional process logic, data access, computer data stored, and user interface are developed and maintained as independent modules on a separate platform. So for each of your information is, number one, residing on a different platform entirely. And from that, the manipulation, there is a logic manipulation, there is a logic process function which is being implemented for you to have access to this information as a user. That means this information, the three components are separated. They are separated. That means for you to access an information, most of the times, the functional logic which is being implemented, you have as a user, you have to meet up with the functional logic which have already been implemented. Most of the times, these things are the essence for this three tier of database management is because of security. Understand that in the world which we are in now, information is regarded to be of a greater value than what it used to be before now. So you discover that so many implementations are being put in place. So many implementations are being developed so that information could only get to the legitimate users. That means if you are not a legitimate user, if you are not permitted to have access to any of the information residing on this server, you can't have access to them. That is for tier 3 application, tier 3 database architecture. Okay. From there, we are going to go to database management system data models. Data models. Data models define how the logic structure of a database is modeled. Your data models define how the logical structure of a database is modeled. Data models are fundamental entity to introduce abstraction in the database. For those of us that have done abstraction, for those of us that have done Java, you could understand that abstraction is being treated in Java, and permit me to say in most of the object-oriented programming. What is abstraction in the research? Abstraction is used to hide unwanted information. Abstraction is used to hide unwanted information. So in a situation whereby you don't want too much information concerning an object in respect to high-level programming language, now object-oriented programming, you discover that you use abstraction. Abstraction is used to hide so much details. So irrelevant details which are not needed, you use abstraction for them. In the same way with your database management system, data model is used for your data model. Abstraction is being used in a situation whereby you don't want to expose so much information, or perhaps you could call them irrelevant information. Irrelevant information per se now could be based on user levels. Based on user levels, like what I was telling you the other time concerning the different kind of database, whereby you have your centralized, your decentralized, and your hierarchical. A situation whereby abstraction is being used to hide information which are not needed for entities. So, for you to implement this, you use abstraction. Okay. Okay. Data models define how the logical structure of a database is modeled. A data model are fundamental entities to introduce abstraction in database management system. Data models define how data is connected to each other and how they are processed and stored inside the system. Data model defines how a data is connected to each other and how they are processed and stored inside the system. The very first data model could be a flat data model, where all the data users, or where all the data used are to be kept in a same plane. Okay? Earlier data were not scientific, hence they were prone to introduce lots of duplication and updated abnormalities. Another thing which we will be talking about here is entity relation model. Entity relation model. What is entity relation model? Entity relation model is a kind of model that is based on the notion of real-world entity. Real-world entities and relation. You are building up your database based on real-world scenarios, real-world relationship. So for you as a database administrator, you discover that this model is what is actually used prominently. You are building up your database based on entities and their relation. Based on their entities and their relation. Take for instance, let me explain it this way. When everyone in that is have taken this course now, when you applied into JBTS, each one of you are different entities applying at a different time. So the first person that applied, a number is being given to the person. The number is given to the person. Then your name is being imputed. Your sex is being imputed. Just like that. Then when the second person also applied, a second number is given to the person. Your name is being imputed. Your sex is being imputed. The course which you are applying for is being imputed. So these are real-world entities having relations. That is, the relations which we are talking here now is your data. The sequence of which your data is actually, your data is flowing. So this is the most prominent kind of data base which is being implemented. Okay. Your ER model, which is your entity relation model, is best used for computational design of a database. Your ER model is based on entities and their attributes. Entities and their attributes. So, take for instance, Faith, you apply and your name is being imputed, Faith. Your sex, female. So your age is being imputed. So these are all your attributes. A number is being given to you. To that number, your name, then your sex, your age. These things are your attributes. Take note of these things. The entities are their attributes. Then the relationship among entities. The relationship among these entities. Take for instance, this 300 level, there are relationships among all of you. The relationship among all of you that everybody at this point in time is taking database course. So when your result is being processed, you wouldn't expect not to see your result for this very course. Okay. Understand that an entity in an ER, which is an entity in an ER is a real-world entity having properties called attributes. We are defining now what is an entity. An entity in a ER model, which is your entity relation model, is a real-world entity or a real-world personality or a personality having properties called attributes. Every attribute is defined by the set of values called domain. For example, in a school database, a student is considered as an entity. Student has various attributes like name, age, class, sex, etc. Now, what is the relationship now? We've seen what is an entity. Then what is the relationship? The relationship now is the logical association among entities. That is what relationship is. The logical association among entities is called relationship. Relationships are mapped with entities in various ways. Okay. So these are the mapping cardinalities. We have one-to-one, one-to-many, many-to-one, and many-to-many. These are the mapping strategy for it. Then the next point here is what is called the relational model. The relational model. The relational model, it is more specific, it is more scientific, and it is more specific, scientific and model than others. This model is based on first order predicated logic and defines a table as an n array relation. An n array relation. Okay, understand that the most popular database model in the DBMS is the relational model. It is more scientific than the others. The main highlights of these are: number one, data are stored in tables called relation. Data are stored in tables called relation. Relation can be normalized. Relation can be normalized. In normalized relation, values are saved in atomic value. Each role is in a relation contains a unique value. Each role in a relation contains a unique value. Each column in a relation contains value from a same domain. Okay. This is where we stop today. Then from next week when we come, we start from database schema. Okay, for your assignment is going to be based on the design of DBMS. The design of DBMS architecture are centralized, decentralized, and hierarchical. So you are going to write the examples. You are going to give examples of the kind of database that exists in this type of database management architecture. Based on the database management architecture, which we have centralized, decentralized, hierarchical architecture. So you are going to be giving examples for each of these type of database management system architecture. Examples for first one, you are going to give for your centralized architecture, you will give examples. For your decentralized architecture, you give examples. Then for your hierarchy database, you also give examples. Please, I'm very sure you got it. This is time for questions and answers. Questions and answers. Please, questions and answers. Question, please. And understand that the email which to submit the assignment still remain the same. SharonChris29@gmail.com. SharonChris29@gmail.com. You could get across to me on my. You can send me text message, call me, or send me WhatsApp on 08133121309 for more clarity on anything which have been said during the course of our lecture. We still have 1 minute more before the class come to an end. Okay. Since there are no questions, please. I'm very sure everybody got the assignment. In case you didn't get the assignment, you can get across to me or on my WhatsApp or my telephone number 08133121309. Please do well to do the assignment because they constitute part of your CA, part of your CA. Thank you very much for your time. Thank you very much. Have a lovely